it was nice.
So I do my classes. Come on. I really want to avoid teaching.
We should put on an hour worth of performance there.
Yeah.
It's
Hey
an
guys, have
easy
you
one.
seen this before?
So smart.
Hey everybody, welcome back to laboratory, computer science class, whatever. Yeah, today we are going to be talking about abstraction and object-oriented programming, which is kind of basically a way to organize data. And that's what we're going to explore about it today. It's more powerful than just organizing data, but that's like a really good start. We'll talk more about objects on Wednesday as well. And yeah, if you guys have any interest in doing like final projects of like, hey, there's a problem I want to solve, or there's a piece of like software project that I think would be interested, I'd be happy to work with you guys to kind of make something happen. But optional as this entire class is. So yeah, with that, go ahead and screen share the slides. Yeah, so abstraction and objects. Yeah, I kind of want to just talk about, so abstraction stuff is a little bit more high level. But yeah, like on a very weird fundamental basis, all your computer really does is like math, and like really simple math, like addition and subtraction and multiplication and division type math. And it builds everything up on top of that. So somehow computers are able to go from this, just adding and subtracting, to like Photoshop, which does Photoshop things, which is not addition and subtraction. That's pretty wild. So the question is, how do we do that? And well, it's kind of what computer programming is all about. We kind of go from data. Everything in Photoshop is actually represented as a bunch of ones and zeros, a bunch of numbers. And then we do functions to them. We have functions that figure out where the mouse is, figure out where you clicked, figure out where you're using stylus, all sorts of things that all come together. But it's obviously a huge amount of work. I mean, I'm sure that Photoshop is millions of lines of code. How do we build that? How do we structure that? So basically, the idea, and we kind of hit on this in the homework, is this idea of abstractions, where or layers of abstraction, where we start with, like, at some point somebody had to write a program or a piece of code that said, okay, whenever you press a key on the keyboard, like the operating system can listen to that and understand what it's doing. And that's like a super low level thing, like probably involves some like really basic operations. But then we're able to just be like Python, get raw input. And that's kind of this layer of it. That's kind of what we talk about, these layers of abstraction, that somebody else, or even you possibly, can go ahead and write code that basically just like hand waves things away. So it's kind of an example, like if we're working with graphical programming, like in Python, like if we made an elaborate scene with Python turtle, like let's say we make a function that's draw a meadow scene. A meadow might have a lawn, so we'd have this function that says draw lawn, and draw some flowers on it, draw a tree at tree 1x, tree 2y, tree 1y, draw a second tree somewhere, and draw some birds. And the beauty of like programming is that if you can find somebody who's written this draw lawn function for you and it works for you, you don't have to write that at all. You just can. So you separate it out into these like layers of abstraction, where like a meadow is this big set, and so you can kind of be like, okay, well, I want to draw a meadow, and then maybe I want to draw people on top of it. Great. Like the meadow's already got this layer of the draw meadow function just handles everything that goes into drawing a meadow. So for instance, like kind of has some little like pseudocode samples of what that might look like. So the draw lawn function might set up where to start drawing the lawn, and then it just draws a bunch of grass blades. This other draw grass blade function. Meanwhile, draw flowers might go ahead and take a number of flowers that we want to draw and draw however many flowers with this draw random flower function. Similarly, draw a tree might be, you draw a trunk and then you draw some branches. So does this kind of make a little bit of sense in terms of, the way we take functions and write functions in terms of other kind of lower level functions?
Yeah.
So we're kind of just taking a big problem, breaking it down into smaller things, and if those smaller things are still too big, we break those smaller things into even smaller things. So, eventually, like, this draw meadow, well, it needs a lawn, and a lawn needs, like, individual blades of grass. So we're going to, draw a ton of grass blades until we have a lawn. Or somebody else on your team, somebody that you're programming working with, or you can import a library, like the turtle library, like is a bunch of code that some other guy wrote that has all these functions, and you just get to use them. You don't need to know how they work. They're just kind of this black box that you say turtle.shape, turn it into a turtle, and great, and it works. That's pretty exciting. So kind of an example from some of the work that I do and have done. So this on the right, or the left, I mean, is a oscilloscope readout. So an oscilloscope is a tool that measures like signals. So this is measuring three different like electrical signals on 3 separate wires from a PlayStation 2 controller. And so it's got this data line that goes up and down from 0 to 1. It's got this clock line, which regularly goes up and down from 0 to 1, and this command line. And so, kind of sidebar, what's going on here is the clock line is setting up, okay, I'm going to set up a communication, and whenever I go low, when the clock light goes low, it says, okay, write, like whatever you guys are seeing on these lines, that's telling me if the data I'm sending is a 0 or a 1. So, the command line is sending from the PlayStation to the PlayStation controller, like, hey, give me some button data. And the controller is saying, oh, well, I've got, up on this line, well, I've got, 0, 0, 0, 1, 1, 1, 1, 1, 1, 0. And the command line is saying, oh, 0, 0, 0, 0, 0, 1. Great, I've got it. And so that's this like communication packet that's going on. This is like as low level as it gets, basically. That, this is like physically having a chip that's like turning voltage on and off, like literal ones and zeros. But you can go ahead and like I and other people like write code that basically puts a wrapper around this. And so you can just, instead of having to be like, okay, listen for the command bit and then read in, the actual ones and zeros for the controller data that's being sent out. You can just be like, okay, controller dot square button, controller dot triangle button, controller dot circle button. Like, I can just I can call this controller library that just handles all that stuff for me. And so it's the idea. So this whole abstraction concept is that we abstract away the actual. We move from, okay, turn on a bunch of ones and zeros really fast to like, step a little bit bigger picture and be like, okay, create a controller packet that says, turn on these buttons. Eventually that might go even higher to, if you wrote a program that, was going to play Super Mario Brothers, for instance. You might have a set of functions that, just says, Mario.fly that, presses the right controller buttons in the right order to, make Mario fly in Mario 3. So it's basically, stepping away from, moving. So abstraction is just kind of this process of moving from kind of in the weeds sort of stuff into like higher level, concepts. And so, one of the ways to think about, you have a problem that you want to solve with computer science is the old joke about, how do you eat an elephant? One bite at a time. So this is another chunk of code that I wrote to change. So it takes in like data from a lighting board, like a theater lighting board, over this DMX protocol. It listens to DMX and stores that value. So I guess all of this code like goes ahead and updates like a LED fixture based on what controls it's getting in, and shows some data. But so what I need to do is, I need to actually just get the data, and then update the actual LED fixture, and then send some of the DMX data out to the console so you can actually see what's going on and show various different things. Just breaking the highest level thing is, okay, have a lighting fixture that works when I send DMX data. And the level below that is, okay, separate it into the different tasks you need to do that. And then, this get input DMX array function, just kind of breaks that task down even further, and so on and so forth. So as you program, kind of, be thinking about these kind of hierarchies and these stacks of how things all kind of fit together. That kind of flows into what we're really going to talk about today, which is objects. And excuse me. So objects are super useful in terms of so we're going to talk about the data side of objects today as opposed to the functions side of objects next time. But yeah, so objects are amazing at basically setting up these layers of abstraction, of making kind of your code make a lot more sense and be a lot cleaner, and they're super powerful. Most programming languages these days kind of are object-oriented languages, which means that basically everything is what's known as an object, and we'll talk about what that is later and how it works. But yeah, I want to talk about data. So let's say you've got a program that queries IMDb or something and looks for a bunch of movies. It has data on them, so you can mess around with that. Maybe you're setting up something that's like cover flow on a bunch of movies with movie posters. So we want a bunch of information about these movies. So one thing that we could do is we're doing all these operations on data. So kind of the naive approach might be, okay, well, I'm going to hard code in every piece of data that I want to use. So we've got 3 movies here: Fight Club, Breakfast Club, and Dallas Buyers Club. It's like, what year are they made? What actors do they have? So I could set up all this for every movie that I wanted to use. But it's got some limitations. Like if we wanted to add a new movie, we're going to have to go ahead and hard code in a brand new movie. It's going to be really difficult to have a program take in input from the outside. Similar, if we wanted to add a new data category, say we wanted to add director, we'd have to set up another variable for every single movie that we wanted to have, which would be, if we had a list of 1,000 movies, that's going to be exhausting. A possible approach might be using lists. We could have all of our movie names in order, Fight Club, Breakfast Club, and then the years that they came out also in order, and then the actors also in order. So I'm going to sidebar on this real quick. We haven't really talked about lists too much. But one thing that's really powerful with lists is making a list out of other lists. This is known as a multi-dimensional list or multi-dimensional array, kind of depending on if you're using a list or an array. But yeah, so we could set up we want to use a bunch of colors in our program, and maybe grab a random color from time to time. So we could, but we wanted them kind of categorized. So we could set up shades of red, and shades of blue, and shades of green. And then we have this array or this list that contains each of those lists.
So it's kind of like functions and functions.
Yeah, it's like a function call a function. It's like a list that is a bunch of other lists. So I'm actually going to pull this up in Python. Let's see bigger. Just cut paste. Should do.
Kind of reminds me of the difference between putting individual HTML pages and then using CSS or something.
That's a great analogy. Danny was talking about, it's kind of the same idea of, if you've ever put it in HTML, made it like a static web page, where you kind of have to set everything up every single time.
If you want to add something in, it's like a nightmare.
Yeah, versus CSS, where it's like, you can kind of change things and it changes through the whole document. That's going to be very relevant to the objects. idea. So we've got colors, and color is this array of these arrays. So let's see. So we've got the first array that we had, comma, second. So I keep saying arrays and I mean lists. They're not 100% interchangeable, but the concept is very similar. So we have our list of lists. And if we want to get an individual item, so if we just went colors, 0, we would just get the first list. And so if we go colors 0, 0, that gets the first element of the first list. So color 0, 2, we get us Ruby. So it's saying, okay, colors, find the first list element of colors, which is this list, and then find the number 2 element of that. It's kind of the visual idea. It's like you have like an array here that's got, or a list here, that is just pointing to all these other lists. So it's a list of lists. And so if you want to access it, you get the first, you pick the number of the list that you want, and then you pick the index of that list that you picked. Yeah.
List that you picked. No,
Say, go ahead.
Wait, can you go back to? I want to go back to the color. Yeah, I want to look at that for a minute. Okay, so you popped in color. So you have shades of red, shades of blue. I see you just made another.
Yep. So I made 3 lists and put them into variables.
Okay.
And then just colors is just these 3 variables, which are also lists.
Okay. And colors. Oh, I see. You just listed, and then you just.
Yeah. So color just contains a list of lists. So yeah, when you want to actually get a single element out of a list, you kind of first be like, okay, here's our big list, and find the sub list, which would be in the box of kind of our main list here, and then whatever's in the index of the sub list. So 2-dimensional arrays are pretty common. You can go even higher. You could have this be a list of lists of lists. Ad infinitum. You won't see that as often. It kind of depends. You might see some 3-dimensional lists if you're doing stuff in 3 dimensions, understandably. Something that's really common that you'll see is working in 2D. A lot of times pixels will be stored as a multi-dimensional array. So you might have an image that's stored as a list of, so each single row of pixels would be a list. And then each row would then feed into another big list. So you'd kind of on your x-axis would be a row of pixels, and then your y-axis here would just be like, hey, pick row 5, pixel 18, for instance. So yeah, this is in graphical programming we'll most often see lists of lists. Similarly, actually, if you ever have an array of strings, so like in Python, strings are actually just lists of characters. So technically, this is a 3-dimensional array because this list, shades of red, is actually storing, what is a list of 3 lists of characters. Because strings are, in Python, technically just lists. So this is actually colors is a list of lists of lists. But that's kind of an aside. It's relevant in terms of back to organizing the data. So we have our where'd I go? So we have this array or this list of our movie names, then our movie years, and then this list of lists of who the actors are. And so if we ever wanted to use, find out, data from a movie, just as long as we were careful and use the same index. Okay, movie names here, number 1. is, okay, it's the Breakfast Club, and that corresponds to this, corresponds to this, corresponds to this, corresponds to whatever list is passed here. And so, we get sensible data. So that's one approach to kind of having more organization for our data in our program. But, it also is kind of error prone. And kind of having a bunch of stuff kind of that has relationships stored between a bunch of different lists can wind up getting you into trouble, kind of depending on what's going on. So here's a situation where I had incomplete data. Maybe for some reason we forgot to add in the year of the Breakfast Club, and we were going through, and maybe you mistyped something, or maybe your function had a function that was finding out something on this and it screwed up. So if this was our data and this was our function, all of a sudden we're trying to find the version of the Breakfast Club that came out in 2013 starring Brad Pitt and Edward Norton. Which, while it might be a great movie, it also doesn't exist. So what we can do is we can use an object. And an object is, in a lot of cases, kind of a very literal metaphor, where we can create a class called movie, and I'll talk about what class is in a little bit. But we can make Fight Club into basically a variable that stores information about movies. So we can make Fight Club into what's known as an object. And so this Fight Club variable is actually an object that contains a name field, it contains a year field, and it contains an actors field. So we're going to create this object and then store our data into it. And then if we ever want to know, okay, so we have, we do the same for Breakfast Club and whatever other movies that we have. So later on, we'll be able to go back, and all of the data about Fight Club that we have is all in one place, just in this variable Fight Club. And so objects, they're super important. So objects are very close. So an object is an instance of what's known as a class. So up here, we had this Fight Club object, and it's part of the it's an instance of, Fight Club is a movie. And so we built this class called movie. And kind of the relationship between it is that, so you have an object, which is an instance, like an individual item of that class. So if we had a car class, for instance, this would be a car, versus the class car is kind of the pattern for, what is a car? It has wheels, it's gasoline, it has a couple of doors. And so we set up so the way that we use object-oriented programming is that we set up a class and then create objects that belong to that class. So basically we say, we'll go ahead in our software and define, or in our program and define what is a car. So then later on in our program, we can actually make cars and use them. So kind of back to our movie example. We're going to be creating this movie class, and it's going to tell us, or it'll allow us to store data about specific movies. So basically, the process is that in order to make an object, we first have to go ahead and define a class, and we do this similar to how we define a function. This class is the keyword that we use. Then give it a name, and then the colon. And then for our purposes, we're going to create this. This is a special line in Python. This is how we actually create. It's a function that allows the class to create itself when we want to create an actual object. So when we want to actually make the object, we use this line, which is the name of the class in parentheses. I'll talk about this a little bit more. So we set up this class. We give it a name. Then inside it, we put this special underscore underscore init underscore underscore parenthesis self function. And inside that, we set up these variables that our object's going to have, that our class is going to have. So It could be a string, it could be a number, it could be a list. So then when we have our object, we can create it with this, just invoking the class name as a function, and then fill it up with data that we want. So I'm going to do movie as an example. So we're going to go ahead and make a class movie. Definite self name. So we're just going to instantiate these as empty strings, or 0 is a good number. So now we can actually create movies. So like Fight Club, movie. So right now, Fight Club is an object. It exists. It's also it's an instance of this class movie. It has these fields: name, year, and actors that are currently just empty. So we could go ahead and actually put data in them. Actually have something. So, yeah, basically the way we set all this up is that, so basically objects, one of their uses is to act as basically as a way to organize data. And so we create these, we set up these fields in our object, or in our class, I mean. So like name, year, actors. And then we can, using the object that we created earlier, we can set the data, and then using it later, we just do fightclub.year. So variable name, and then start with our...
Wait, I'm kind of confused. Okay, so do you do the class first or the object first?
So do the class first.
So
basically make the pattern for what the objects look like, and then you can build actual objects.
And then the object comes from that.
Yeah.
Or object is assigned that or something.
Yeah, so class is kind of like a factory for objects. So it tells you like what is in the object.
Okay.
And so when you create them, you can then use them. It knows what fields it has.
And they're specific to that object.
Yeah.
So you can't just make a bunch of classes and then assign them other. Just trying to figure it out.
So I'm going to go ahead and fill the rest of this guy out.
So the class is the movie.
Yeah.
And the object is Fight Club.
Mm-hmm.
And then, but movie could be any movie. So,
yeah, so that's kind of the side, the layer of abstraction here is that, so basically, let me move down. This is not a good class today, I'm sorry.
So if the class is a movie, but can't you put that class to other objects that are movies as well?
Absolutely. So
that's, I guess, my question.
Yeah, so we're going to create, so we've got this Fight Club equals is a movie. So I'm going to create this Breakfast Club variable, which is also a movie.
Which one's the class?
So the class is movie. So I'm making these objects that are movies.
Okay. Yeah.
So Breakfast Club is also a movie, and it.
Okay, so class basically is a little box of things that define things. like a movie.
Mm-hmm.
A movie does this. A movie does this, and then you can assign that class to different objects. I mean, you can have different objects assigned to that specific class. Like say you had Pokemon. Right?
Mm-hmm.
So you have like grass Pokemon and fire Pokemon, and but Pokemon in itself could be a class, and then within that you make individual objects that would be fire Pokemon, but it would be or something like that. I mean, it's just a way of organizing information.
Classes are a way of organizing information. We don't. I'm not talking about it in this lesson because it's kind of complicated. You can actually have classes that are like meta classes. So with extending the Pokemon example, you could have a class of Pokemon that contains like information that all Pokemon share.
Have. Right.
And you could have you could break that down. You could have subclasses like fire type Pokemon and grass type Pokemon.
Yes. Yeah.
And then your individual Pokemon would be the objects.
Yes.
So you'd have like your Charmander, which would
be an object.
Yeah, Pikachu would be an instance of an instance and so instant. I'll use the word instance a lot. An instance is a specific object. So like, here Breakfast Club is an instance of the movie class.
Right.
Breakfast Club here is an object of the movie class. So you'd have Pokemon as a class, and then Charizard or Charmander would be an object. And it would be a specific Charmander. You'd have multiple different Charmanders running around with all their different moves and different owners and stuff. So yeah, it's very much like the object is, it very much corresponds to like a regular object. Like we could have a water bottle class, and then we'd have two water bottle objects, my water bottle and Whitney's water bottle.
I have a philosophical question about how data is organized in terms of computer programming. Is it somehow affiliated with how westernized science and thought organizes information?
Probably. There's probably a lot of, it's actually really interesting. So the object-oriented model, and we're not really talking about it in the slides. So kind of the idea with objects is this idea of this concept. One of the powerful things with objects is this concept of inheritance, where you can have these what are subclasses and superclasses, where your Pokemon class might have a bunch of different subclasses for your grass types, your fire types, your water types, XYZ. So it's kind of this like hierarchical model. So it's very taxonomic.
I was just thinking about that because I was thinking about how we learn how things are grouped together. Is completely different than, say, other cultures, how they group things together. So I'm just wondering if all these computer things are slowly moving into the direction of thinking all in one way.
Well, it's interesting. There's a kind of a newer, so one of the things that's kind of fun about object-oriented programming and programming in general is that it's very new. Like object-oriented programming really caught on and exploded like in the late 80s and early 90s. So this is like a pattern. So beforehand, like putting much shit into lists was like kind of what you did. And just like kind of made sure you kept track of those lists pretty nicely, like carefully. Versus now that we have these objects which store. So we're just using objects right now as like data storage. I'll switch back. I think a slide I probably should have put way earlier in the deck. Big takeaway about objects is that objects let us hold structured data. So we started talking about data in terms of, we had integers, we had strings, we had floating point. And technically those are all objects. They're just kind of built in.
Okay.
So, like a list is a really good example. So a list is like a variable that stores, multiple instances of data. You could have a list of all of our birthdays. That might have, that would have 4 numbers in it. So objects are kind of this extension of that concept of, it's basically like a custom data type that allows us to store like things that are logically connected.
So like with all those movies examples, we are basically now able, like by creating a class, we're now able to create variables of this movie type. So so we have these integer type variables that we can create, and they can only store integer digits. We have these string objects that we can create that are built into Python that store words. And now we're saying, okay, we need more than that. We're going to create our own data types. And so we're going to create this class called movie, and it's going to store everything I need to know about a movie. So it's going to have the year, it's going to have the title, it's going to have the director, it's going to have whatever we need.
Kind of like the idea of making data.
So, like in our movie example, we're storing like the multiple types. So we've got, a name, which is a string. We've got an integer, which is the year. And importantly, it's all logically connected. So, if we're working with this variable, Fight Club or whatever, we're able to, write on hand. We know, okay, well, I've got this movie, so I can I have access to its year and its actors and all of that stuff. So, it's this way of kind of grouping everything together in this nice little package. So other stuff I've got. Yeah, so kind of the way that, and you'll see this a lot, this dot notation. We have this object, and it has some data that we want to pull out of it, and so have the variable's name dot this kind of field that has like year, and so 1999.
So turtle's an object.
Mm-hmm. Yep. And that's. Objects are interesting in that, let's see, I think we're actually just about done with slides because this was a garbage class today.
What?
Garbage class today. One thing I want to warn you guys about Python, Python's weird in that it's very like loosey-goosey.
Because it's snake.
He's
sneaky.
Yeah. So one of the things you can do with Python, which is not very common in most of the mainstream languages, is like Python will basically just like let you glom on things like as you want at runtime. You can just change everything around. One of the things it'll let you do, so I'm kind of creating this kitten class. It has two data members. It has number of paws, and it's got a name. So I'm going to put this variable mittens, which is going to be a kitten. It's got a name mittens. It's got some paws. Then I'm going to throw 6 tentacles on it. And Python is like, great, mitten's got tentacles now. That's awesome. Python doesn't care, and it will let you do that, which lets you do some interesting things. But it also puts you at risk of typos. Well, let's say you're racking through and it, Mittens has, oh, I know it's got paws, I know it has this name field, so I'm going to give it a name, but accidentally used a capital N here. Python's be great. Fine, you've got Mittens.name, and then you go and write way down later. You're trying to find the name, and it's like
no.
I just got a blank string here because that's what it started as.
Oh.
And you're going to be like, where did my name go? And just because, yeah. Python is happy to take an object and bolt on additional data to it.
Well, there must be an advantage to that as well as a disadvantage.
Well, yeah, so it's kind of interesting. And now that I've got a little bit more experience, it does make me think. So if you're ever doing anything in 3 dimensions, I want to do the Unity game engine is a super popular option. It's free, and you can do a lot of cool stuff with interaction with it. And so whereas like the traditional object-oriented model is this hierarchical model where, let's say you have a animal class and it has underneath it, 2-legged animals and 4-legged animals, and underneath that has, has animals with tails and animals without tails. So you have this big tree of, and they all kind of, everything inherits, maybe this like, everything breathes, and that behavior is defined up in the animal class. And that kind of filters through everything. You're just kind of, you're building this big elaborate taxonomy. Unity uses what's known as this component model. So whereas with the object-oriented model, you kind of have this relationship between things that is a relationship. So like, a cat is a animal, or is a four-legged animal, which is an animal, which is a living thing, which is an object. And everything kind of flows down through that hierarchy. So those hierarchies can be really deep. Whereas the component model is kind of the looks like a duck, quacks like a duck, it's probably a duck model, where you'd have like, okay, I want a duck, and so I'm just going to like chunk out, okay, well, I have this quack module, and I have this like walk like a duck module, and like, boom, I've got a duck. And so it's a much more flat sort of structure. But that's not necessarily super relevant information. Yeah, so is everybody super lost at this point? Because this is a terrible class.
I'm not lost.
Does this make sense?
It makes
like it again.
logical sense.
Yeah, so I'm going to kind of go back over kind of the, so we've got our object instances. We have our class that defines that. So class is like making a pattern that says you've got stuff. And in order to make a class, we use this class keyword, all lowercase, and we give it a name. And for our purposes, we want to give it this special init function, which is initialize function. And inside it, we can use the self dot whatever name we want. Actually make a real example. So our movie example. Name self.year self.actors. So this is setting up this pattern for us that we're gonna be able to make movie objects, and every movie object is going to automatically come with a place to store its name, a place to store the year the movie came out, and a place to store what actors were in the movie. And so just basically like copy pasting like this pattern to create your own classes. It sets you up for having whatever data that you want to have inside it with a self dot variable name. That'll set you up to have, things that you'd be able to be like, okay, let's create this Fight Club object. It's going to have a year. It's going to have actors, and it's going to have a name. So yeah, it's kind of like, so this would be a way to basically, if we wanted to, we could then set up a list of these objects. That way we'd be able to go and look through our movies, and all the data about Breakfast Club is stored in one variable. All the data about Fight Club is stored in another variable. Yeah. Because, questions, thoughts?
I feel like we've been using these things, we just didn't know what they were.
Yeah. So especially, I don't know, I'm going to try to figure out how to organize this way better for next time. Because next time I want to talk about, so much like, programming is all about data and doing stuff to data. Right now, I'm only talking about objects as a way to kind of store and structure data, all in kind of one nice package called an object. Objects can also have functions. And so an object can, yeah, so like, for instance, let's bring up the turtle again. Turtle is an object. This turtle object, turtle dot for it. And it's kind of a big example, and this is where some of the object-oriented stuff gets a little like confusing because sometimes it gets more abstract. But basically, when we call turtle, turtle is the whole package of stuff that makes the turtle draw, and so it's got data in it. Like when we want, so let's go ahead.
Well, what's the difference between turtle being an object, or being an object, and being a program?
Yeah, so turtle is an object.
It is an object.
And so we can use it to write programs that do stuff.
Okay.
But yeah, it's got.
It's not like an application that it would be.
No.
Okay.
My commands. Right on.
I feel like I want to see like because I'm huge on flowcharts
Mm-hmm.
and maps. I want a map of all the things that we've been learning and how they. Does that make sense? Is there a way to visually like put all this information into some sort of like map of like object, and then with an object you've got, I don't know, I feel like it, maybe because I'm just a visual person, I want to put it.
Yeah, I mean, we all have to whiteboard and see what I can do. Whiteboard time, everybody.
Oh yeah, whiteboard. That's the whiteboard. I feel like it's a little bit like doing an outline, you know, when you learn how to do outlines for reports, where you have like your big points, and then it's broken down into your smaller points.
Turn this over this way. Yeah, so programming. We have data and we have functions. So data is stored in objects.
Oh, see? Oh, I love this.
Hey, Chatham, can I ask a favor?
Yeah,
Can you use a black pen?
can do.
I can't see with the glare on the screen.
Yeah.
Thank you.
Actually,
angle it a little differently.
let's go over this way. I can run on the glass.
I think you can read it if you just use black pen, because I can see the other writing on the whiteboard.
Okay, I think we're trying.
We're trying something else here because the glare was bad.
Thanks, guys.
Maybe I'll want to turn. Let's see if this is better.
Ooh.
Oh, that's way worse.
Yikes.
Yeah.
Oh. Oh, you can see that, kind of.
It's maybe a little bit better. How are you at reading
Backwards.
Backwards. Does it show up backwards to you?
Oh.
Probably does.
Yeah, maybe? I can't tell.
Does it say add or does it say data?
Oh, I think it says data. It's okay. Yeah.
Oh,
I think it automatically
nice.
Everything's backwards in Australia anyway, right?
Yeah.
Yeah.
Well, the water flows down the other way, so
Yeah, well, we're just upside down.
yeah.
I'm actually hanging onto the roof right now.
Yeah. That's why
Yeah,
all the
that's
animals have pouches. Falling out.
So yeah, so yeah.
Fun.
So data, and we have function. That's how he's making it worse. Hooray!
No, that's good. That's good. Thank you.
So data gets stored in objects.
And then that includes class, and then all the lists and within lists and all of that, right?
Mm-hmm. And so objects have types.
Oh yeah.
You go simple types. So our basic built-in types like integers, string,
Mm-hmm.
which is actually kind of a cheat. String is actually usually a complex data type. Floats, lists. These are, we named this to built-in actually. So basically all the languages that we use will have like a bunch of types that are built in, like your basics, your integers, your floats, your whatever.
Mm-hmm.
Then are like other types. Sort of spelling. So other types, we define them by creating a class.
Okay, got it. So there's built-in types and then types that you can define or you add to the data. Or am I like?
Yeah, I mean, it's basically like a built-in type would probably another type that we define by a class would probably have, it'd probably be like a composite data structure.
Mm-hmm.
So, might have multiple things going on. Might have, so like our movie example. So we had a class that was movie that made objects
Mm-hmm.
that had a name slot and a
Right, and then had all those lists and then
and then functions we'll talk about later. Functions are functions change data.
Okay, changes it,
Or moves it around,
moves
or
uses it.
uses data.
Okay.
Translates, draws shit to the screen.
Yeah.
Function actually seems like nouns, verbs.
Verbs. Yeah. Okay.
Actually gonna erase that because we don't care about functions today.
But objects can be functions.
Like it's kind of technically functions are objects.
Oh, functions are objects. Okay. I knew there was something there that connected the two.
That's where things get weird. Like objects are fairly are more straightforward to think of when we're thinking about like a movie or a kitten or things that are actual objects.
Mm-hmm.
Versus
They can get like real abstract,
Okay, got it.
like they can things like a string builder class,
Yeah.
or like iterators. These are like kind of deeper
Okay.
topics that just get kind of weird and like
Yeah, we don't have to go there.
yeah.
I like the noun analogy.
Yeah, and so like we might have an object, and it might contain an integer, like year, for example. I don't know what points are on that. This might be, it's got an integer, it might have a string. I might have another integer or something. Let's get an example. Name. Yeah. They're Oscars. So we've got this movie object. So we can create variables that are movies. Wow, the glare is just horrible on that.
I can still read it and know what's happening.
So we've got our object, and it contains this integer, contains this string, contains this integer.
Mm-hmm.
So it's kind of this
Yeah, it's a
hierarchy. Little boxes that we kind of pack things up in. So.
And you might make a function later that will draw on that object with all of that information as well.
So say again?
You might create a function later that needs to draw on that movie object with all of that information, and that would be like where you expand that out, right?
Mm-hmm. So you might be like going to add, like you have a website that needs to like dynamically generate a page from a database that has all this information in it. You have all these things stored as objects in your database that are these like discrete things. So you can be like, okay, well, as long as I find the Breakfast Club object, then I can find all the data about a Breakfast Club from that.
Yep. Cool.
So.
Okay.
So like, if you're working with databases, like you probably have a program that would send requests to your database for data, and then store that into objects that would correspond to a single record. So you're able to kind of work with that data all together, and so none of it doesn't like lose part of it somewhere, or so you're able to all work on it like logically within your program as each individual record. So you'd like create a class for let's say you're working with a donor database, for instance. You might have a class that was like a donor class that would contain all the information about a single donor, or there would be a pattern for that. Might have it would include their name, their address, their email, or whatever, their giving history, and you'd include. So then you could make donor objects that you could populate from your database, and then you could have your program working on these donor objects.
Mm-hmm. Yep. That makes sense.
Mm-hmm.
Cool. Do you have any other questions, comments? Cool. Thanks for showing up and spending time with me. I get lonely otherwise.
Thanks for putting the effort into it.
Yeah.
I hope this helped. Today's slides were just garbage, just straight garbage. So I hope this part helped.
No, it did.
Awesome. All right, take it easy.